Hey, pre-algebra. Happy Friday. We've made it to the end of a week. You believe we've been doing this online learning over a month now? Crazy stuff. Hopefully we can be back soon, but we'll see what happens in these next days and weeks. So today we're doing lesson 9-2. We're going to talk about prime numbers and composite numbers. Okay? Prime numbers are numbers that have only two factors. Okay? Think of like the number 5. Now, factors, this word we have had in math before, but it might be a little rusty in your memory. Factors are numbers that multiply together to get a bigger number. So what are the factors of 5? I can think of some numbers that multiply together to equal 5, 1 times 5. But that's it, right? There's only two. It's only two numbers. So this number 5 only has two factors. So that's why we call it prime. Okay. Another example would be the number 2. Notice the number 2. Can you think of any numbers that multiply together to give us 2? I can only think of these two. So 2 is a prime number. 7 is a prime number. All I can think of is 1 times 7. Those are its two factors, right? This one, though, is not. I think that was a typo that I put it in there. Why is 9 not a prime number? Can you tell me why? Because think of the factors. Certainly 1 times 9 works, but doesn't 3 times 3 work? So 1, 9, and 3, don't count the other 3 twice. It has 3 factors, so it is not a prime number. I'm actually glad I put it on there by mistake, so I could explain that. It's actually a composite number, this thing. Composite numbers are numbers that are not prime. They're numbers that have more than 2 factors. Consider the number 6, right? What are numbers that we can multiply together to get 6? 2 and 3, 1 and 6, right? So that one has 4 factors. So 6 is a composite number. How about 10? Definitely 1 times 10, right? 2 times 5. So that one also has 4 factors. Some numbers even have more than that, like 12 would be one example. 1 times 12, 3 times 4, and 6 times 2. That one has 6 factors. So if a number has more than 2 factors, we call it a composite number. Hopefully that makes some sense. The number 1 is neither prime nor composite. Here's why. The number 1 has only one factor, the number 1. And so it doesn't have 2 factors, so we can't call it prime. It has to have 2 factors to be prime. And it definitely doesn't have more than 2, so we can't call it composite. So 1 is its own little category, so watch out for that. So the first thing that you're going to do is you're going to decide if some numbers are prime or composite. So here's the easy way to do these. Think through your math facts, and if you can think of a math fact that equals that number, then it's not prime, it's composite. So think of like 15. I can think of 3 times 5, right? And also 1 and 15. So that one has 4 factors, so it's composite, right? If it has more than 2, it's composite. Can you think of any math facts at all that multiply together to give us 23 besides 1 and 23? I can't. That one only has 2 factors, 1 and 23, so it's prime. How about 18? You think of any? I can. 6 times 3, 9 times 2, right? So that one has a whole bunch of factors, so we're going to call it composite. Can you think of any numbers that multiply together to give us 17? I can't, so that's prime, right? How about 6? 2 times 3 works. 1 times 6 works. That one has 4 factors, so we call it composite, right? How about 21? You say it out loud or in your head? That one's also composite because of 7 times 3, right? And 1 times 21, right? How about 49? Prime or composite? That one's also composite, right? Because 7 times 7 is 49 and 1 times 49. So that one has 3 factors, so that's more than 2, composite. How about 29? Can you think of any math facts, multiplying facts that equal 29? I can, so prime. So that's how that first section will work. Then they're going to have you do what's called prime factorization. Okay, prime factorization is showing what prime numbers multiply together to give you a bigger number. So when you see that phrase, prime factorization today, think factor tree. And you've done these before. I did these with the 6th graders earlier this year. We're going to do some factor tree. So remember a factor tree, you think of numbers that can multiply together to equal that bigger number, and then keep going until you can't make the numbers any smaller. 6 we can keep going to 2 times 3. 2 is as low as we can go, then that's a prime number, right? 3 is a prime number, that's as low as we can go. There's nothing besides 1 times 3 that equals 3, right? So circle them when you get to the end. How about 10 is 5 and 2? 2 I can't go any lower, and 5 I can't go any lower. So here's the prime factorization of 60. Put them in order. 2 times 2 times 3 times 5. There it is. Those are the prime numbers that multiply together to give us 60. And you can find them out by making a factor tree, just like we did. So let's do another one. What's the prime factorization of 90? So I'm going to make a factor tree again, right? You can start with any. 9 and 10 is a great start. You could do 30 and 3. It doesn't matter what 2 numbers you start with. You'll always end up with the same answer at the end. 9 we can break down further, right, to 3 times 3. That's as low as we can go with those 2, though. And 10 can be broken down to 5 times 2, right? And that's as low as we can go. So now we put them in order. times 5, but then I also forgot the 2 at the beginning. Put them in order, okay? So 2, 3, 3, 5. Good, I got them all. So there we are. There's our prime factorization of 90. So at the end, don't forget to put them in order like that. One more. Prime factorization of 24. Just so you can see one more of these. Do this with me on a sheet of paper in front of you. So 24, there's a lot of different options. We could do 12 and 2. We could have done 6 and 4, right? 8 and 3. Doesn't matter which ones you start with. So if I do 12 and 2, there's one prime number. And 4 and 3, right? There's another prime number. But 4 we can keep going with. 2 and 2. And then we're done. So now let's put that in order. There's 3 2s. And then a 3. And there we are. There's the prime factorization of 24. Hopefully that still makes sense back from last year. Okay, then your book's going to teach you a new word today. Monomial. A monomial is a single chunk of either just numbers or just variables or numbers and variables. Do you see? Here's a single chunk of a number, right? 5. There's no pluses or minuses or anything. This would be 2 chunks. 3 plus 5, chunk, right? This one's just a single chunk. Here's just a chunk of numbers or variables, just the letter C. And here's a chunk of both together, right? So it's a monomial. Mono means one. Okay, and so this is a monomial chunk. It can either be a number by itself, a variable by itself, or numbers and variables together in one chunk with no plus or minus signs between them. They're going to have you factor monomials today. Here would be a couple examples of that. They want us to factor these monomials. So we're going to make a factor tree. So what we're going to do is we're going to pull out the number, and then we're going to separate out the variables. Can I break this number 11 down any farther? Is there anything besides 1 and 11 that I can multiply to break it down? There's nothing. So my factor tree is done. It's 11. Okay, and then we're going to break down the variables. Let's break down our r's. That's 4 r's. So r times r times r times r is what r to the 4th means, right? And then there's only one s times s. Then at the end, add in your numbers, and there you go. We have factored that monomial. We've split it apart into smaller pieces. Let's do that with this bigger one right here. So first of all, we're going to take the whole number, and we're going to make a factor tree. This one we can break down a little bit. 7 times 4 is 28, right? 7's a prime number. I can't go any lower, but 4 can go lower. So there we go. We broke down our whole number. Now let's break down the variables. A is a times a, right? And b is 3b's, right? b times b times b, b to the 3rd power. And then let's put in at the beginning of this our whole numbers. So 2 times 7. I would highly recommend using circles for your times. Don't forget to put one between each number or letter instead of x, because if we do have the letter x show up, that could get really confusing, right? So that's why I'm using dots for multiplying. I would encourage you to do the same. All right, let's show you just a couple more of these just so they're making sense. Again, let's pull out our whole number, okay? 10. If I factor it, that's all the lower I can go. So I'm going to put those two numbers first. Okay, now let's do each of the letters. There's only one of each variable or one of each letter, so I only have to list each one once. And there we go, and I'm done. Now here's a tricky thing. Pay close attention. If you have a negative 1, okay, you always have to include a negative 1 in your factoring. Okay, I'll show you what that means. Let's ignore it for now, and let's do the factor tree of 18. Okay, 9 and 2, 2 is a prime number. 3 and 3, 3's are prime numbers. Okay, so I'm going to do 2 times 3 times 3. Now, remember, it was a negative number, so I have to add negative 1 to the beginning of mine. Because 2 times 3 times 3 gives me 18, but it's negative 18. So to make it negative, you put a negative 1 in your factoring. Okay, does that make sense? We'll do one in our assignment where we have to do that too. Okay, so if it's a negative number, when you're done making your factor tree, add a negative 1 to the beginning of your list, okay? Then we have 1m, so times m. And then we have 4n's times n times n times n times n. There we go. And we've completely factored that monomial. All right, let's do a few problems right out of your work, guys. Number 1, the first section you're just answering P or C. Is it prime or composite? Remember, the easy way to do these is can you think of any math facts that equal these numbers? Okay, and here's another hint. All the even numbers besides 2. Remember, 2 is not composite. But all the even numbers besides 2 are composite because they all can be divided by 2, or 2 is a factor of all of them. Okay, so here's an even number, okay, that's bigger than 2. So we're going to say composite because composite numbers have more than 2 factors, right? Here they are, 1 and 26, but 2 times 13. Do you see how that one has 4 factors? Anytime you have more than 2, it's called composite, okay? Here's number 2, 19. Can you think of any math facts at all that equal 19? Plus, it's an odd number. I can't. There's none besides 1 and 19, so that would be an example of a prime number, okay? So there's the first two of that section. Let's do a couple of the second section. Now you're going to be factoring these monomials, these chunks of numbers and letters and variables, right? So let's pull out our whole number first, and let's make a factor tree for 14. That's an easy one. There it is. It's done already. So 2 times 7 times, and then notice we have 3 A's. So A, and there's your final answer. Okay, here's a negative one. Remember what to do with a negative one? We're going to ignore that negative sign for a second. We're going to make a factor tree of our whole number. There it is. So 3 times 3. Now remember, if it's negative, what do you have to add to the beginning of your list? Hopefully you're saying -1, so we'll add that to the beginning of our list. Because 3 times 3 is 9, but remember we needed -9. So to make it negative, we add a -1 there. We have 1 R, right? See that 1 R? 2 S's times S times S, and 1 T times T. And there we go. There's our final answer. Okay, then they're going to have you do the prime factorization. Remember, this fancy phrase means make a factor tree, right, and list off all the prime numbers that can multiply together to get this. I wanted to do a bigger problem because some of them are bigger numbers, and they're tricky. Notice this is an odd number, so your brain might be saying, ooh, I don't know if that you can divide it by anything. Try dividing them by 3 if you have an odd number and see if that works. Let's try that. 243 divided by 3. 8 times 3 is 24. Notice this is going to work. 81 times 3 equals 243. So let's start with that. Okay, and then always try dividing by 3. Now there's a prime number. We do know some numbers that multiply together to give us 81, right? 9 times 9 is 81. And both of these 9s we can break down further, can't we? And 3 times 3. That's as low as we can go, though. So let's write our prime factorization. Let's use dots. 3 times 3 times 3, and then 2 more 3's. And there we go. There's the prime factorization of 243. Here's another big one. I purposely grabbed these bigger ones. Now notice this one ends in 0. Anything that ends in 0, remember, you can take the number without the 0 times 10 to get that, right? So let's start that way. So here's 450. We'll start with 45 and 10. That'll make it a little more manageable, right? 10's easy. That's 5 and 2, and then those are 2 prime numbers. How about 45? Can you think of 2 numbers that multiply together to give us that? I can think of 9 and 5, and 5 is done. And then 9 is 3 and 3, isn't it? So remember to put them in order, right? We got 2, okay, times 3 times 3, times 5 times 5, right? And there we go. There's the prime factorization of 22. So hopefully that gets you off to a good start. Don't be afraid to contact me if you get stuck or rewatch parts of the video to see me do some of these problems again. I think it's going to go well for you today, though, because we have done this in the past. Have confidence that you know how to do this, or you can pull out of your memory past times where we did this. Have a good rest of your Friday, everybody. Happy weekend.